Oh, and speaking of recording, hopefully you guys saw my message on Slack. The recordings for the cohort orientation, as well as our first study group, those are up. That's mostly like, if you missed it for some reason, you can go through it. I'll try to record all the sessions. There's certain times I don't like record it, but for the most part, I try to record it in case you miss and stuff like that. Speaking of which, though, like I still really encourage you guys to come like live and everything like this. And when I say encourage, I mean like strong encourage. I won't like, I don't know. I would say maybe I won't make you feel bad about it, but I might feel bad if you're like purposely missing it. If you're like, oh, I don't really want to come in. And mostly it's because it helps, first of all, it helps you with the schedule. Two, it's that it helps you ask questions like, that you like don't quite understand versus a video, I might do something and you're like, but why? But why? And you can't say anything right then and there. So anyway, that's why I record it, just so you guys have access to it. And of course, maybe we talk about something and you're like, wait, we talked about this. Maybe I can rewind it and check this out too. That can also be useful. And of course, the student resources page is not just my recordings, but also other recordings from other instructors and see how they explain the same topic. They do different styles and different ways of doing it. So it's always useful to go through that, especially if you're like, just want to see a little different. You want to solidify that knowledge. Cool. All right. So other kind of business news. So our Mod 1 project, and you guys could probably see this from the calendar, is going to officially start, I think, August 26th. Yes, August 26th is our first module, which, approaching pretty quickly, right? So just kind of give you guys a feel for what's going on. Our cohorts usually will, after they're doing their project, they'll actually do kind of like a show and tell. And so I believe that's happening today. And I think actually it's from Dara's other cohort. So Dara's leading that. And I'm trying to see what time it is real quick. Yes, so it is today at 6 p.m. Eastern time. So that's coming up in a few hours. So if you can make it, awesome. I will send you guys a link on Slack, but also know you can find it as the study groups on learn.co. So and it'll show up as show and tell. But I'll share that link explicitly. So you guys can check that out, see what people have done. They'll do their non-technical presentation. You can get a feel for that. There's also a couple recordings too, I think, on the student resources to show you like what, when they did other show and tells. So that can be useful to kind of look at and stuff like that. Yeah, Devin.
I know you said that there are going to be recordings on the other website or on the other on the site, but is today's session going to be recorded specifically, or do we know yet?
It should be recorded. They usually record it. Sometimes they might not, but I think I can ask Dara, but I'm pretty sure that she'll record it. So that would be up to. Cool. Good question. And Eduardo, I can see your face now. Welcome. Okay, so let's get into it then. All right. So I'm going to start sharing my screen, and that's how I always start. Usually, well, not always start, but we will basically be talking about some kind of like I kind of say it like the basics, which makes it sound like it's not important. Like, I mean, not important. It sounds like it's easy. It's definitely something that takes a lot of effort to go through. But before I talk about this, from section 1, talk about introduce of what is data science, which I realized I never really talked to you guys about what is data science, like what are we doing here, right? Hopefully you guys have a feel for it. You're not like, oh, data science, like I thought this was a cooking class. Oh, we have a chef too. I think Jeffrey was a chef, right? Yeah. Anyway, so data science. So let me ask you all, like, does anyone have an idea of what data science means, or a quick like sentence or 2 sentences explanation? And there are no like, I'm not gonna be like, oh, that's wrong. But when do I try? Yeah, Devin, go for it.
From what I understand, data science is generally using math and graphs to tell a story about the data that you are analyzing, basically.
Yeah, good. I like that. Telling a story, and I think that's a big part. Anyone like to add anything else to that? I think so. Yeah, go ahead, Eduardo.
Sure. Just basically being able to also be able to gather the data and then clean it and gather the insights and then communicate that.
Yeah, good. Because a good part of data science is that data, right? It's in its name. And so I think you guys both have actually really good parts of data science. And I think of the data science, like what a data scientist does, is kind of on a spectrum. So I'm just turning off my notifications here. And hey, Melvin. So what I like to think of data science is that it's this whole process. And this is where I really like this data science life cycle. It's from this website, sandeep.co. And what's it called? It basically, you can think of it like this whole process that just keeps iterate over. But the first part really is, before you start anything on data science, is really understanding what a business needs, or who you're talking with. Like, usually as a data scientist, you're not doing it completely by yourself, but you could be doing it for yourself. But usually you have some kind of goal in mind, like, what am I trying to achieve? And this is where, like, our number one are business understanding. And business, business can be like, a profitable business, a nonprofit. For example, I worked with schools before and stuff like this. Like, this can be something like, what do they care about and what do they need? And then from there, it's about, as Alfredo said, collecting that data, collecting, cleaning it, mining it, however you need, basically get information, right? A large amount of information as best you can. And then going through that process, and this is what those numbers 2 and 3 are, that data mining, data cleaning, we'll do some of that stuff. And then once you have the data, you have to see, well, what's in it? Like, what do we have? Like, what does this heap of data look like? And this is what this data exploration is. Basically, it's exploring it through math, statistics, graphical analysis, right? Like Devin kind of mentioned, a lot of math, right? A lot of coding. We use coding to basically optimize the way we explore and go further. And then after that point, usually we want to say, okay, now that we see what the data kind of looks like, can we make any predictions? Can we basically, what can we pull out of this to say, okay, now that we do this, what things can we do later for the business? So for a school, for example, a school might say, well, what are things that we're doing to help our students do better? Well, do better could mean a lot of different things. That could mean test scores. That could mean, what's it like? Maybe they rate the kids, like rate how well they're doing. Maybe it's talking about grades, things like this. Like, are they going to new schools? Or are they going, like, if they're higher, like let's say high school, are they going off to college? Are they going to a secondary school? Like all these different metrics, right? And then before you get all this data, after you explored it, you start basically things like, okay, how can we like make it so it's like, how can we guide the business to do something from this data? Basically, like, what do we do next? And that's what this feature engineering, predictive modeling. Usually predictive modeling is kind of like what you probably hear machine learning, deep learning, stuff like that. That would be predictive modeling. But it can also be something relatively straightforward, which is usually linear regression. Linear regression is more statistical modeling than, it's like machine learning, but usually it's a really good go-to. And basically we can do that stuff to kind of help predict, say, okay, these are things that we can do to help improve whatever the business wants. And then our data visualization, this is kind of like part of the data storytelling, is you're basically saying, okay, I have this bunch of information, usually a bunch of math, but I want to make this easy and understandable for our business. And that's where this kind of part comes in, as well as actually communicating this aspect. And you probably have seen, like, actually I can probably look this up, but maybe everyone's seen this, a Venn diagram of data science. And it's all slightly different, stuff like that, but I'll just put this in, oops, computer, it's like, no. So a Venn diagram of data science. So it's probably gonna be something like the very first ones in here. Let's see, yeah, thanks. No, I don't want that. There we go, this is close enough. Okay. I wouldn't phrase in these ways, but that's okay. Basically, it comes down to the sense of saying, okay, this mathematical knowledge, basically that your statistics, your mathematics, understanding this, it's on that green circle. And then we have our hacking skills, which really is computer skills, like software engineering. So a lot of times, like, software engineers might not necessarily know all this mathematics. So there's kind of a hard place for them to cross over. And then, like a data scientist, really it comes down from the domain knowledge of understanding the business needs and stuff. And I think a big part of this, like, domain knowledge, part of that also is like what we kind of call soft skills, which I don't really calling it like that because it sounds very like, ooh, like soft skills. Like, it sounds like off-putting, like, I don't know. It doesn't seem like it's like, oh, it's not important. They're soft skills. They're things that you can just learn on the side. They're really important stuff. And I think that's one's domain knowledge. So I think, Jenny, you said you were interested in archaeology, right? You went to school for archaeology. I think we actually had a student who was an archaeologist in a past life, and they actually were using, machine learning to, I think they wanted to apply, I didn't have the student, so I can't tell you exactly, but they wanted to use it with some, like, I want to say something like ancient writings or like something like that with like machine learning. And so there's basically like, there's so many different ways you can apply this knowledge, and that domain knowledge of understanding the field is super important. One example of this is one thing I really, I can do is American Sign Language. And so it turns out there's a whole bunch of domain expertise you need to understand for the American Sign Language to do stuff with this. So one thing I wanted to build was an automatically classifying, different hand shapes, which are basically letters in American Sign Language. And I was looking at the research that people have done, and you find that there's a lot of people who don't understand how American Sign Language actually works. They have an idea of what it works, but they don't actually have that expertise, domain knowledge. And by expertise, I just mean like basic knowledge of like talking to someone who, who knows how to use American Sign Language, maybe a linguist even. So this is a really important part. But then kind of like this part that I think kind of gets forgotten in data science is that communication, is that in order to take all of these parts together and communicate them outward. And that's actually where that module 1 project show and tell today, if you can go to it, that's what it's focused on. It's about how do you communicate your results off to someone else. So a really data scientist, like I like to say, is like a math statistics person, a software engineer, computer scientist, and preferably someone who's knowledgeable in the domain and someone who can communicate really well. So you have like all these parts in here. And so if that seems like a lot, it is. And in reality, no one person is that one thing. And so that kind of gives you guys an advantage too. If you just said like, oh man, like I can do maybe one of those, but not the rest of those, that's okay, because that's something that you have a strength now, and you can strengthen the rest of those parts. So this is something I kind of want to kind of give you guys a little feel for, like, what to look for in data science. And on this whole spectrum of like what a data scientist is, it can go all the way from like more like data engineering, data collection, all the way over to like the machine learning aspect, where you're mostly focusing on machine learning and production level. And there's people who are more closer to like, the communicative part, like, okay, like we take all these parts together and communicate them outward. So a data scientist has a huge spectrum of like where exactly you can go. Okay. Any questions or anything you guys want to add in, or things I've talked about? All right. You guys are always a quiet bunch, so. Now that's a bad thing. Okay, so I want to talk about a couple things that we kind of was here from section 2. Yeah, section 2. So talking about bash and then command line stuff, and then Git. So real quick, who just raise your hand if you have a Windows computer, just so. Okay, so I have Devin, Andy, cool. So you guys both have Git bash working then? All right, so just know that we'll usually use Unix commands, which is not what Windows is native in. If you have a Mac computer, you are using Unix. Usually Unix is kind of considered for a lot of software developers really great, especially for data science stuff. A lot of stuff is written in Unix in mind. And part of the reason why is because a lot of data scientists will actually use Linux, which is anyone familiar with Linux? Like, ever at least heard the term? Okay, shake your head if you like, no, I don't know what Linux is. Okay, I see some nods. Okay, so Linux is an operating system. Like there's Windows versus PC, and then there's like the true best operating system, Linux. But basically, you can see my bias already, right? But Linux basically runs a lot of the web interface, and a lot of like usually the cloud. A lot of the cloud is running on Linux or some form of Linux. If you ever seen a Chromebook, Chromebooks are actually running Linux underneath, on top of it, or Linux underneath it, whatever. But the point is that it uses something called the Unix system, UINIX. And basically, it's the way the file structure. I'm not going to go into the full thing because we're not a computer science class, but you can go into the whole reason, like what these different operating systems are doing. But the main thing you would have to care about is what kind of programs and how can you interact with it. And for the most part is that we're going to do everything mostly on our own local computer, but there's a lot of data science problems that you can't do on your local computer. So one thing you have to do is you have to log in through the cloud. And one of the things with cloud is like, well, most of those computers are Linux computers or some kind of Unix computers. That's not 100% true. Like there are some, like Microsoft Azure basically uses a different kind of operating system. But like I think something like 90% of the web is run on top of Linux. So it's like a huge amount of computers are doing that. So it's useful to know these commands on how to actually interact with your computer. Okay, so I'm going to go through some. And that's kind of like the why of why you're doing this. Basically is that at each point, you will, at some point in your career, you'll be navigating on a terminal, terminal command line, that little black box. You can think of like, if you're from the 80s, like black box with green text, it's kind of the same idea, but navigating by remoting into a cloud server. Okay, and mostly are Linux or Unix based. So it means that if you know how to do Unix, and how to navigate through that, you basically know how to go through any computer that's at least important to you on the web. So this is the reason why we want to learn this stuff. Let's see here. Okay, I want to make sure I said everything. So navigating. So I think this is best if I actually have a little, let me go ahead and open up. Oh, I could just go like this. Okay, let's do a new terminal. So we can actually see what this looks like. So this is like my terminal. I think actually, no, I haven't showed you guys this. This was on class. So this is a terminal. You can see here, sometimes you'll see something a little different up here. If you open up in like your Mac or Windows computer, if you're using Windows, I strongly suggest using Git Bash because your commands are going to carry over that way. For Mac, I think it's just called terminal in the actual application. Something similar will pop up. You can customize and all that stuff, but for the most part, you basically have this box where you can type into things. So there's a few things we can do. So the first thing to do is actually be able to navigate, right? So one thing we can actually navigate is understand the directory folder structure. So just like in folders, like you can see right here, I'm in like, let's say resources, Flatiron, and you can see all these different folders. And then within these folders, for example, we're going to do data science, Python basics. And you can see some extra folders and go into here. And you can see, you know, for example, our different like files, right? We can do the same thing on Bash, right? So the way we reference a few of these things is that if you see this like single dot, know that means the current directory. Basically, the current folder you're in. That's what the dot is. Double dot means directly above. That star, if you ever see a star, basically means a wildcard. It means anything that matches anything like this. And I'll kind of show an example of this. And then this little squiggle guy, which I used to call the squiggle for the longest time. It's a tilde. It's like usually on the top left of your keyboard. That is basically your home key. So basically, it's where your home directory. And Unix always has some kind of home directory that you can reference into. Usually it's by user and stuff like this. So we'll actually see what this looks like. Okay. So, but first, before we actually show you like how to navigate the whole thing, it's good to kind of have a visual example. And so you can kind of see like when I showed over here, you can see, for example, the different folders. And then in those different folders, I can have different files, right? I can go back up to a folder. I can go to a different file. You can see multiple parts here and so on, right? So to kind of visualize this, and I think this one works really well for me. There's kind of like this master directory right here, usually signaled with a backslash. And then usually for Unix systems, we have like a bunch of different folders. Usually you'll live mostly in this home, but there's sometimes we'll navigate into these other special folders that where applications live and stuff like that. And you can basically navigate into these parts. These little arrows right here, just know the reason why they're little arrows is because they're actually like symbolic links. So you can tell like it's just this hierarchy. Sometimes there can be things where you kind of get looped back into the beginning or some place that you didn't expect to. But for the most part, all the file system is in some kind of, what's it called? Hierarchy. Okay. So that's a good visual. Yeah, go ahead, Devin.
So when talking about the arrows that are pointing like from bin to the other bin folder, are those literally the same folder, just in two different locations? Or are they just two separate folders that happen to have the same contents or somewhere in between?
Yeah, I think in this specific image that I just grabbed online, is not my own. I think this is actually a reference to something called a symlink where they have a folder here that literally is the same folder that would reference each other. But you can have things that are the same name. So for example, you could technically have, like, let's say Eve is here. You could have another folder called Eve up here, and that's perfectly valid. And they don't have to be connected in any other way other than the fact that they have the same name. Okay, a good question. Cool. Yeah, and feel free, you guys don't have to like, I appreciate like raising your hand. You guys can just like unmute because sometimes I won't see you all too. So if I move on to something, just like, oh, and just interrupt me. Okay. And I can drag on for a while. So definitely interrupt me if I need to. Sorry, I lost my train of thought. All right, commands. So first thing is pwd. Basically it says, where am I? So all you gotta do, type pwd, enter. And it says, hey, look, I am in my directory users, vGuyslinger, developer, workspace, Flatiron. So that means that's the directory I'm in right now. And the next command I could do is I can do cd, so I can move somewhere. So I can actually move into, let's say, the folder above. So I can do cd ... So that would move me up a directory. So I can do now pwd, and you can see here, I now am in this workspace directory that goes users, vGuyslinger, developer, workspace. If I wanted to go, let's see here, I'm trying to think what the best thing to do. If I do cd dot, okay, what was the dot represent again?
The current directory.
Current directory, right? So I do cd, so I'm there. So anyone got an idea what will happen when I do pwd?
You're in the same directory?
Yeah. You'll
Yeah.
stay there.
Yeah, good. I'll be in the same place. So good, right? All makes sense. Life is good. So this is where I can do, like, for example, cd the home directory, that little tilde. I don't know if you guys can see that too well, but that is a tilde. Okay. And you can see here now, pwd, you can see that is my home directory. Okay. So that basically is a shortcut for me to be able to navigate into here. Now, I know, for example, my next directory down is developer. So I could do cd developer. And you can see now, if I do pwd, developer. So I can also do cd workspace. And now I can do pwd, and I'm now in this full thing. I also could have, if I go back to my home directory, right? You can see I'm right here. I can navigate folders in there. So I can actually do cd developer / workspace and go and navigate directly into that directory. Okay. Well, make sense for everyone?
I have a quick question.
Mm-hmm.
So since you're doing this in a Jupyter notebook, this won't automatically like show up in your terminal. So if you open like your terminal separately, it'll be different, right?
Right. If I open up another terminal right now, it's more like, you know, for a Mac. Melvin, you don't mind if I'm going to mute you for a sec. Is that okay? Cool. All right. Sorry, if you're on your Mac and you open up a new Finder window, like for Windows Explorer, you have like a little folder, right? And you can click through and do stuff in there. If you open up another Finder, right, that Finder window is not going to move, right? It's going to stay like, say you open up like developer and it stays there, and then go navigate in a different Finder, go onto workspace and all that stuff. And this won't change. It's kind of the same idea. It's like another window of looking through. However, when you do make changes that involve like folders and files, and we'll show like how to make files or make folders, for example, that will actually populate throughout your whole computer. So every terminal will actually now have that updated part. It just won't show it up there right immediately.
Okay. Will it do that in Jupyter, or do you have to be doing this in your actual like terminal?
No, you can do it in Jupyter. It's actually using the same thing.
Oh,
so,
okay.
Cool. Yeah. Awesome. Good question though. Okay, so so I kind of also showed you cd into like multiple directories. Quick thing, if you kind of notice like, wow, Victor types really fast. I can't even see how well he's doing this. First I'll show you, I can also go up multiple directories. So I can go up to, and then does anyone got to guess where this will be if I do pwd? If I go up 2 directories from workspace?
Your home workspace.
Yes, right. So the guy slinger, good. So I was about to say, thank you. If I do a cd now, I can type dvl. I'm like, oh, like, see, I'm bad at spelling. el. I can just do tab now, and that'll automatically fill out. It's like, oh, I know what you're talking about. I can also do the same thing with workspace. It's a dw tab, and I'll fill it out. And this will tab out to anything that is similar to this. So like, if there's multiple words, for example, let's say there's workspace and work. If I do wo, it will only tab out to work, because it's like, oh, I don't know, like, should I go workspace or work all the way through? And so just be aware if you're doing tab, it doesn't completely go through. But it's a quick thing, so you don't have to type very long stuff. Okay, so I'm in my workspace. I also want to go into Flatiron since I know this specifically. So one thing we can do now is actually start exploring. And so a basic exploring is ls. Okay, and we can just do ls, and you can see here it basically just lists all the things that are in this directory. So you can see actually from here, we're in our Flatiron. If I go up to, let's see here, well, this is my Flatiron part. You can see random, admin, cohorts, blah, blah, blah. And you can see from here, same thing comes with admin, cohorts, curriculum, random, right? Blah, 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 going this through. You can also pass flags to a lot of commands. So ls-l is one thing I like to use a lot, and it'll list everything in a list, right? So ls, like a list of things, -l in a nice form list, and that makes it easier to see. This also shows like the date it was created, some extra information about like writing permissions and stuff. So this is stuff that, like, honestly, there is so much you can learn about Bash. Don't feel like you have to absorb all of this, and you'll find little things that work really well. There's another part, a flag that's useful in here. It's also -a, and ls-a will actually show you hidden files. So this can be really important when you're doing stuff that basically automatically creates stuff. For example, like, we'll talk about like a .gitignore, and basically by default, Unix will hide .files. And sometimes it's useful to actually go into that .file or .folder and actually do something with it. So this is useful, and you'll see this, for example, is from Jupyter Notebook. This is just referencing, these are hidden, it's references to ... and . Okay, so above the directory or the current directory. And then this DS store, you Windows people or anyone who uses Linux, you won't have to worry about this. Just know this is a very specific Mac thing that basically it's like for them to cache things through and everything. For the most part, you can ignore these things. There's not really anything useful information on here. If you delete this file, for example, it's not gonna like destroy anything. It just helps speed up Mac find things and stuff like that. Okay, so any questions about LS? No, sound good?
I had a couple of questions.
Yeah, go ahead.
Is there anything that those switches stand for, or is to help remember what they do?
Oh, the dash L and the dash A.
Yeah.
Mm-hmm. Yeah. So they're usually referenced as flags. So if you're like ever trying to figure out like, oh, what's the flag for this? It's a dash something. I don't actually know what they stand for, and the thing is, this has been around for so long that I almost wonder if like no one knows what they actually stand for. But one thing you can do for a lot of commands, you can do a -H, which will basically show you, oh wait, nope, -- help, sorry. What do you mean -- Okay, never mind. Sometimes you can do a -H, and sometimes that will give you information. Other times you can also do man and then the command, and this is man meaning manual. So you can see here, and this will give you all the list of all the different little flags you can have. And you can see, you can sport, I don't know them all. I don't use them all. I mostly use the ones that I really care about. But this is kind of a fun thing to kind of go through, and you can definitely explore and as you get more and more experience, you're gonna find the things that work out well. But exactly what they stand for, I don't know. Cool, good question. Cool. So also clear, it's nice to have. It'll clear out your screen. It doesn't like delete anything. It just makes it so it's nice and easy to read. For Mac, you can still scroll up and you can still see the stuff from the previous part. Okay, cool. So I'm going to go ahead and show you a few other commands in here. So I'm going to mostly show you head, more, less, nano. I don't know if actually the curriculum talks a lot about this, but I find these are really useful. So I'm actually going to go do ls, and I'm going to see, okay, different parts. I'm actually going to go into my resources, and I already know what the next one is, but I'll do ls and see, okay, Flatiron School resources. So you can see that tab just goes all the way off to the side. I'm just looking through it real quickly, and I want to find something that I want to try out. Oops. See, so this is a good example. So you can see there's probability, right? And there's also projects. So if I do PR tab, it'll stop at pro because it doesn't know which one to go through. But once I put another letter, for example, I put B, I do tab now. Yeah, there it goes. Okay, you can see it fills up the whole thing. So I'm looking for a file. So I have this file right here. So this is why I got to this point, is that I want to show you guys, well, what's in this file? So we have a file, what's in it, right? So one thing we can do is we can do head. So we can do head, let's say Titanic, .csv, and .csv you'll see a lot of our comma separated values. So basically it's a list, it's a file where every row has commas separating the values, and then new row, new row, new row. So head Titanic CSV will actually display the first, I think it's the first 10, yes, the first 10 lines. So you can see basically from this folder here, these are the first 10 lines going here. So that's really useful when you like don't want to go, like if you have a very large file, you don't want to print out the whole thing. You might just, as a data scientist, want to see like the very beginning. So, okay, cool. I can see, for example, this part right here, which is just the heading, right? And then I can see some data listed underneath here. So that's really useful. Another similar command is more and less, which I know there's a little joke about like why it's more and less, but it's going through. But this one, for example, will actually, oh, I think this is a big enough file. Oh, no, it's not. So you can see here, it actually has a lot going through, but you'll notice how I do, if I just go down, I'll see the next one. I can also go up. So this is useful like if you want to see chunks at a time. Again, this is still useful for very large files because you don't want to load the whole file. Like if who's ever tried to open up like a really big like Word doc or a big Excel file, it like takes forever and sometimes it crashes in the middle of doing this. This can open up those kind of files, you know, like a CSV file that would normally take Excel a long time to load up. You can just very quickly look at this and it'll only load that one chunk. and you can see it in the middle here, and you can go all the way through. You can also use space to like go faster. And then to get out of this, you just type the letter Q, and you can see a dash comes up, and now I can go back to doing my stuff, right? So I'm going to clear this out so I can see it better. Less basically does the same thing. You'll see what less does. Literally the same thing. So you can do more or less. It doesn't really matter. At least I don't think it matters. I feel like someone will say, oh, like someone will look it up, it's like, oh no, it does matter. But I've never seen a difference. All right, and then there's a couple ways we can actually edit directly on the terminal. So this is something that I kind of show because sometimes you have to log into a computer with basically no graphical interface. Basically, there's no way to use a mouse. So it's sometimes useful to like edit the file right then and there. Also, since I'm already here, it might be easier just for me to edit it since I'm already here, especially if I need to add just one quick thing. So one basic one is something called Nano. So Nano basically is a built-in text editor on here. And so I can actually go through here and edit some stuff. So you can see, for example, like I want to change this to a 10, right? Or, you know, whatever it was, right? And I can go through, navigate through, and I'm just using my keyboard now, my mouse, not my mouse, my little arrow keys and stuff. When I want to save it now, let's say, for example, I change this to, I'm going to change this to 2. Okay, so I'm going to save it now. You can see on the bottom here, it tells you some examples what to do. So all I have to do is do that little arrow means control. So I do Control X, and it'll say, okay, you changed some changes. Do you want to save them? I click Y for yes, N for no. I'm going to click no for this time. Or Control C, which is that little arrow kind of pointing up, C. That's what that means, is Control C. So I'm going to press no, and basically exit out there, and nothing has changed. Okay. Another editor that I personally like to use is VI or Vim. This is a more advanced editor that you can kind of go through, but it kind of allows you to navigate through a lot quicker. I would suggest if you're looking to say, oh, like, you know, I want to learn a way to edit files on there, VI, Vim is a useful thing, but I'm not going to go over it because there's a whole lot we could talk about for VI and Vim, but it does exist for most computers. So it's a useful thing to learn if you want to take that extra time. Okay, so those are a couple things that aren't talked about in the curriculum, but they're useful. And cat's one of the last one where basically it's kind of like head, but it reads the whole file. So you can see here it printed all 890 lines, which you have to be a little careful with because if you don't want to print out the whole thing, it could be useful or could not be useful. Cool. All right. Any questions about these kind of commands? Minus Vim. Vim I kind of didn't really like talk much about. All right, cool. All right, so making some changes. So let's say we're actually in our thing now. We want to make some changes. For example, let's create a folder, right? So one thing we can do is, I'm going to clear this out. You can see ls here. I'll do ls-l, it's just a little easier. You can see there's a file here, California Housing Tests.csv, Titanic.csv, right? So one thing we can do, we can actually make a directory. So we can make a directory with mkdir. Okay, and I think the reason why all these are like really short, you notice like man, for example, MAN, I think it's because programmers refer to this, programmers in general are just lazy. They don't want to type a whole lot of stuff out. So that's why you'll see a lot of things very short and stuff like this. And again, it's just stuck since it's been around for so long. But mkdir makes a new directory. So if I want to make a new directory, and I'll make it capital, you could use lowercase, but it's case sensitive, but just be aware that I like to make my directories capital. So I say like new directory, okay, which is the same thing as new folder. You can see here, new directory, right? And so if I actually were to go into, let's see if I can go here real quick. You can see my new directory actually exists here. So if I actually want to make a new one after that, so say like make directory new, right? You can see the different capitals, right? You can see it pops up right here. So it does actually affect your computer. It's making new files and such, or folders. Okay. So a couple other things, touch. So touch is a great way to just make a quick like empty file. So for example, if I am in here, I can just do touch new file. And this will actually create a new file that basically is completely blank. So this is nice when you have to like basically just make a new file that's like, oh, I just need to have an empty file to dump stuff into. Okay. A couple other things. Okay, so CP and cat again. Oh, okay, I know why I put that in. So CP is going to copy a directory or copy a file. So for example, I want to copy a new file. I can say, well, let's go ahead and put something in the new file, right? Okay, so I saved it. So now we actually have stuff. You can see, for example, in new file, there is some stuff in there. Oh no, did I not save it? It's called new file, right? Oh, I see it. Okay, there it is. Hi. It just didn't print on the new line, so that's why I didn't see it. So if I do like a new line now, you can now see if I go, there it is. A little easier to see. Okay, so I want to copy this file. I can do copy new file or CP new file, and then I give the name of my new name I want it. For example, say other new file, because I'm really creative. Okay, so now if I do head of other new file, you can see hi again. So I can edit this stuff and make a new file, and you can see here now the new file exists. Okay. So that's a quick way to make copies. You can also, for example, make a copy. So let's say I want to copy this guy, new file, but I want to copy it a directory above. So I can do that as well. And if we go here now, you can see it's there is already another new file, but that was a few seconds ago. If I go up here though to what's it? Statistical distributions, we should see other new file. Okay. So that's a quick way for us to like make copies and move them around, stuff like that. All right. Last thing I kind of put in here because it's super useful is cat. So the curriculum actually does this, so I want to show you guys what this does. So let's say, for example, you can do cat dash dash, and then let's say go into new file. So I'm gonna actually close it so it doesn't do anything. But you can see there's just hi, right? So I can actually add some new stuff to the new file. So if I click enter here, you notice nothing happened. What's gonna happen now, basically it's waiting for you to type in something. So for example, say, hello, and then I click enter. How are you? Okay, so I have new stuff. And then stop this, I just do Control D, and you'll see, okay, that was interesting. But you'll see now, I actually added that, I appended it to that new file. So you can see here, hi, what, hello, and all that stuff. So this is a good way to put the stuff in here. Now you're like, all right, that's cool, Victor. Like, that's an interesting way to do things. This might be something useful, for example, if you just want to add, sorry, Windows getting a little bright. You might want to do this if it's like add, like, let's say the last part. So remember we could do something like head, let's say Titanic, right? So those are the first 10. Let's say I want to say, oh, I want to add these first 10 like lines to the bottom of my file. What I can do, for example, head Titanic, and that double brackets or double, greater than signs, right? What that is, that will basically, okay, append this to the bottom of your list. So if I do that to new file now, you'll now see, oh, I want to close that. Okay, good. I just wanted to make sure it closed because otherwise it wouldn't load, right? You can now see it gets added to the end of your file. So this is useful, like if you want to add something to the very end of it and stuff like that. Note, if you ever do one little bracket, and I do this right here, it will not append it, it will completely erase it. So now if I go ahead and show you what that looks like, you can see, was it new file? Yeah, you can see it completely erased everything and completely overwrote. So be very careful with this, with the terminal, because basically the terminal is like, oh, all right, no confirmation, just whatever, right? No, I'll just do things. So just be aware of all that stuff, okay? Any kind of general questions about what's going on with these different commands with little bracket and double?
I kind of just have like an overall question.
Yeah.
So what's an example of like when someone would use all of this in the workplace?
Yeah, so one thing you might do is if you have a data file and you want just like you want to explore it really quickly. So one thing is like if I tried opening up a very large, let's say an 8 GB file that is just a list of, comma separated values. The problem with this, so I tried opening up with a normal editor, it's going to, if my computer can handle 8 gigs, it'll load it up, it'll take a while. If my computer, let's say it's like a 100 GB file and you only have like 64 GB of RAM, well, it's going to try to load the whole thing in there and it might basically crash. So this might be a good way to just navigate through it very quickly to see what is in this thing. Okay, I see what it's in there. Now I can go ahead and proceed with like using Python to process it and stuff like that. Cool. All right, Cool. And then I think, Melvin, did you have a question too?
Oh yeah, I was just curious. So cat we would use if we just want to like manually put in our additions, and then the two greater than equal signs would be like we already have something on file we want to add to append with.
That's right. Yeah. So that's kind of what you would use cat for. Usually these are like very quick commands that you'll see frequently. Like if you ever go search for something like, oh, how do I do this on Stack Overflow, which Stack Overflow is really, really great. Sometimes you'll see these commands. So I want you to be a little familiar with like how they kind of work. Do you have to memorize this after I just said it? No. Will you pick up some of these? Yeah. Will you forget some of these? Probably. Some of these you might never touch ever again. Or you will say, oh, that's right. I remember doing that one time, but I don't remember. That's perfectly fine. But at least you're familiar with like the things that you can do and what people are trying to do. Okay. And again, the like amount of knowledge that like Bash includes is so vast. I don't know it all. I don't think anyone knows it all. Maybe there's some people who know it all, but they might only speak in Bash. I don't know. But anyway, yeah. And then one thing I guess I should say about the cat thing, you can also make it with something that doesn't exist. So I can do, for example, like test.txt, which does not exist, right? There was no full file in there. And I can actually type in here and this will actually appear too. So this will also work fine for making new files, which again, why you might see this more and more. Okay. All great questions, guys. All right. I realize I'm taking a little long, so my little time management is not the best. So I'm going to go through a few other things. So one thing is your move. So if you're moving a file, this MV basically allows you to move it. So if I want to say, for example, let's say move my test to a directory above, this will actually physically move, well, not physically, I guess digitally move my test file, test.txt, into the directory above here. Okay, so this allows like you move things around. You can basically move it, like say I can move a file that's like, okay, it's a directory above. I can do test.txt, and I want to move it to this directory here. I can do like dot, and that will say, okay, move test.txt to this directory, and that works fine too. So you'll see now data, and you can see test.txt. Okay. I also can use move to rename things. So if I want to do move test.txt, I can rename it to new name.txt. I'm just calling it .txt, but I could also just call it new name. And what will happen, that will actually move the file to its new name. You can also do this if you move the file, but now it's called new name. I can move it up a directory and then I'll also call it test.txt. Okay. So this is similar to like copy, but it's actually taking that same file and moving it over. It's not making a copy. Okay, so you can see if I go up here, I moved it up to here. Okay. Cool. Any questions on that? Okay. For the most part, to be quite honest, you probably will move files when you have a graphical interface for a long time, just by clicking and dragging your folder and stuff like this. But it's good to know that this is what's coming up on here. All right, I'm going to show you one last command and then not to show you how to use it because it's kind of dangerous. It's something called rm. Can you guys see this okay? It's not too small, right? Okay, cool. So rm is basically remove. Remove doesn't have any confirmation. You have to be very careful with this. So if you've been working on this thing, for the past, week, and then all you do in rm and remove, it can remove your file and basically says, all right, cool. I don't need to ask you for permission. Just to show you how easy this is, I'll do ls-l to see what's in here. If I want to remove, let's say, this new file, I might just do rm new file, right? And then it's gone. No confirmation, not in the trash bin, it's gone, right? So be very careful if you ever see rm. I mostly am showing it to show you, like, be careful of this. This is why you don't copy and paste code and say, oh, see what happens. Sometimes this can be really bad. Also, all right, I'm going to ask you guys. There is a way to basically delete your whole computer files, and it has no confirmation. And it's like super short. Do you guys want to see that power, or do you rather not even like see some on? So what you would do is you basically do rm/star. Oh wait, if I wanted to make it recursive and make it force it, that will delete my whole computer's files with no confirmation. So let's not do that. So this is how, like, for example, the power of Unix, but also like with great power comes great responsibility. You do not want to destroy your whole computer. There's also that stuff you can do. For example, you can try to hide files and stuff like this. Like, for example, the dot files are automatically hidden, but you can say, oh, let me try to hide this. I tried pulling this as a prank as one of my friends back in college. I was like, well, I was going to hide his whole desktop directory. And it's like, ooh, like, this is funny. He's like, what if I hide his whole hard drive? And I'm like, oh, that'd be really funny. And I'm like, let me test it on my computer first. And good thing I did, because I tested my computer and basically nothing happened. And I was like, oh, well, that's dumb. And I restarted my computer and then it couldn't boot up anymore because it couldn't find the hard drive. So be aware of these kind of things. So this is actually a great little segue. I'll show this extras. Man, SSH. These are things I'm not going to go over. There's things that you'll see in the future, but they exist. But this is a great segue into using Git. So Git is kind of like a version control, almost like a backup thing, and this can be super useful to actually know, keep your keep track of your files and what you've changed and stuff like this. So I'm going to kind of skip over this because we're on a long time. But basically, version control system, so VCS, sometimes you'll see, basically is keeping track of all the different changes you have. There are a few options. So as you might have done at some point, is you might just rename a bunch of files, version 1, version 2, or you might do the thing that everyone does at some point, it's like final. No, really the last final. No, really final, stuff like this. So this is kind of similar. I'm pretty sure everyone can relate to this at some level, is doing that final, right, going through. So usually Git is a better preferred system because this is really annoying to have to go through. And you can imagine one big disadvantage of this is that, sure, this is the final part, but let's say you made a change at some point, you'd have to physically go into final, for example, see where that change is, copy and paste it, move it over into OK final. And it's like, oh, this is a huge mess and stuff like that. So, and the other part too is that what is final? Is final, what change did I make? Is there something special about final? What if I want to go back to actually test that out? This is where it's like, well, that's really messy. There's some versioning tools. So for example, Subversion was very popular for a long time before more modern kind of computers, about 20 years ago, Subversion was very popular. Git came about, and Git has kind of been the standard now, for, I don't know, at least 15 years, 20 years, possibly longer than that. But the reason why it was really cool is that one, it basically keeps a versioning of your files, which basically kind of acts like a backup, though you shouldn't think of it like a backup. But it basically keeps track of all your different files. It also shows you can work with multiple people. Subversion would actually lock people out, say you can't edit this until I'm done with it. Git allows you to asynchronously work together and then merge things together. So it's a really great collaboration tool. And also it just saves the changes, which doesn't sound super special, but if you save just the changes, you can basically figure out where you made these changes and then actually roll things back or incorporate new changes and stuff like this. So this is where it gets really really useful. Okay. Also, Git is super common. I think even the curriculum has this little comic, XKCD, which I think, Devin, you were wearing a shirt at least earlier with XKCD, right? Okay. So XKCD, if you do not know, xkcd.com is a great little web comic. He puts out Monday, Wednesday, Friday little comics, stuff like this. You will, if you ever export that, you'll probably find every other one completely relevant to whatever you're doing. It's in technology and science. So it's a really great kind of one to go through. But basically this is going to be how most people feel, and this is how I mostly felt about Git for a long time, is basically you just have a bunch of commands memorized and you just do those. You have no clue what they do. You're just all right, just do these things. That is true for a surprising amount of people in technology and stuff. So my goal for you guys, and I'll be honest, you're not going to know it all after doing the section 2. You're probably not going to know it all even after I talk about the whole thing. It'll take some time. I do have a couple of resources that I personally suggest because that's how I learned Git. So I'll kind of point out that at the end of today's study group. But I want to show you guys what the basic Git flow is. Okay. So and also know if you know how to use Git, people will be good. They're going to be good. We can work with you. So it's a useful thing to have on your resume, or at least be able to say in an interview. So basically, Git has main parts. I'm going to start drawing a little bit. Basically, it's something called your Git working directory. And and then your staging area, and then your actual repository, okay? And so what happens basically is that you will like type along, you're making all these changes and stuff like this, and you're like, cool, you save and all this stuff. And this is basically working in your working directory. This is all the stuff like you're changing and stuff like this. Then what you do, you're like, okay, cool, I made all these changes. Like, I wanna go ahead and make this as I wanna commit to this change to say, this is something that I wanna save, essentially, to go back on or like reference later on. So let's say, for example, you are working on the Macbeth project. And on the Macbeth project, you figured out how to get rid of asterisks, you figured out how to get rid of, I don't know, dashes or something like that. You're like, cool, I figured those two parts out. I want to save that as like its own thing, right? So that might be multiple lines of change of code and stuff like that, okay? And you've been saving a long way through. So you actually will take that change, you'll commit to that change by adding it to your staging area. And basically the staging area is kind of like this buffer, like you're on deck, like if you ever play baseball, like, oh, you're on deck, you're coming up next, right? And so then from the working directory, it's like all the stuff you normally do. Your staging area is kind of like, okay, these things are ready to be committed to my repository. And your repository is kind of like your history of all your different changes you made. And then after you put stuff in your staging area, you basically do a commit. And I keep emphasizing commit, meaning that like a commit is kind of like you are committing to this change, right? And when you commit your changes in there, this will be git commit and adds to your repository. And now you will have that will be part of your history, and then you can keep working on top of that. And so basically your overall flow will basically be a git add with files. Like, so you can add multiple files. So if you can do git add, file 1, file 2, file 3, or you can do git add file 1, git add file 2, git add file 3. Those are both valid. That'd be your first step right here. So you add the files that are relevant that you want to save. Then you would do a git commit, which basically is saying, all right, we're going to take the stuff that we've added into the staging area. So this git add puts in the staging area. So this is kind of like the stuff on deck. It's like, all right, all this stuff is ready to be committed. It's not committed yet, it's just ready to be committed, okay? And then from that part, we say, okay, git commit -m, a message. Basically, it's saying, all right, we're going to give a message to say, what are these changes? What do they represent? And this is where you give like about a 50-character, explanation, very quick but concise, of what changes did you make. So I might say, for example, if Macbeth, if I figured out how to get rid of the asterisks and the dashes, I might say, removes dashes and asterisks in file, right? And that would be like my commit message. And so this right here basically will add it now to your repository, okay? And basically you might do this multiple times. You might say, okay, you git add, git commit, and then keep working, work. Oh, cool, I want to save some stuff. Git add, git commit, work. Git add, git commit. So you'll get this history of like different things. Basically they get stacked on top of each other of your different changes. And then what happens is if you have a GitHub repo, what you want to do is actually push this up, like your changes, all your commits, to your online repo. And with that online repo, what you're going to happen with that is it's going to basically sync up with what you have here. And this is kind of like the nice part where it's like, one, it's kind of like a backup, but two, also keep, so if somehow like your computer, craps out, you have that information still on your online GitHub repo. But also another part of GitHub is that you can actually share your code with other people. So other people can see your code. Other people can see like, oh, look, they've been doing work and stuff like this, okay? That's where this git push is. So this git push basically takes your repo and pushes it up to like the cloud, right? My wonderful cloud, my purple cloud. All right, so yes, so that's kind of like the basics of like what you'll do. Like you basically these are like the 3 commands that you basically will do over and over again. Like, and this is the thing, like you could memorize this and like never know exactly what it does and be all right. When we start getting more complicated stuff, that's when we have to start worrying about saying, okay, what are we going, like how are we going to act on this stuff? And this is where like git status, git diff, and git log will show us the changes and things that are like this current status of where I am in my work. What are the differences from last time I saved? What is the basically the history of my different commits that I've done? So maybe I want to see like what did I change in the past? Maybe I put in a bug in there that I didn't realize. That's what kind of git is. Now I'm kind of short on time, realize. So one thing I'm going to do, actually going to come back to this. This is kind of a good way to stop. For next time, we'll talk about these commands and then into GitHub itself and actually how to collaborate with Git. For the most part, we're going to be focusing a lot more on GitHub. Collaboration can get very advanced. There's a lot of things you can do with that. This is something maybe we can talk about honestly throughout the course. We don't have to like say, oh, tomorrow or whenever we talk about it and say, okay, we don't have to talk about it ever again. We can keep going visiting back and forth to this because I think it's a really useful tool that once you figure out how to use, it's really powerful and really awesome. Okay, but the main thing I want you guys to take away is this structure right here, this working directory, the staging area, and this repo. I want you to think whenever you're doing, like I know you guys are working on the different lessons right now, is when you're doing a git add, you're taking it from your working directory, putting it to your staging area. And then from your staging area, you're committing it to your repo. And that's the kind of the process you're going back and forth on. Okay. Any questions or anything you guys would like to add on to this basic workflow command-wise?
So when we're pushing back up to GitHub, that's not like there's a step beyond that to actually submit labs to Learn Code, right? Or is that it? We just, yeah, okay.
Yeah, and that's our, I think it's something that's a little outdated. I think it says like, submitting the lab. That's not something we do anymore, or we're not doing. There's some change in how that worked. I think it just hasn't been updated. So just know for the most part, really it's your own practice. I'm not going to be grading it. No one's going to be looking at it yourself kind of deal. But I think it's more, you should think of it as more practice. Okay, but good question, because yeah. And I think next time too, I'll talk about like, how you make your own repo and how you can kind of keep that track of it. There's a suggestion I do that's different from the Learn curriculum that I think makes more sense for what you guys will do. For now, just keep doing what Learn talks about. It's still relevant. It's still important to know how to do it. But I'm going to show you guys a different way of doing it that I think makes more sense for what you guys are doing versus what Learn is asking you guys to do, if that makes sense. Okay, cool. Any other questions before I have to?
I have a quick question.
Yeah.
So for most of the labs, I've just been like git adding and git committing and then pushing it like at the end because I haven't been making like a lot of changes. Is that more so when you're doing like the bigger projects and you're editing over things or you're adding a bunch of like new code at the bottom?
Yeah, and that's for the most part, it's for bigger projects as they get bigger and bigger. It's good practice to do. It's not necessarily like you said, like finish the whole thing and then do git add, git commit. Those are perfectly valid. But as you get like, I think it's one of those things like if you practice doing it when it's not really important, it's easier to do it when it is important. So I'd say like try to think about like, when you make a change, like if you make a new function, like go ahead and do a git add, git commit. Usually think of it like as logical changes.
Okay.
Makes sense? Cool. All right. Any last questions before I head out for you guys? Okay, sorry. I'm going to show you guys one last thing. I have to mess someone. Okay. So one last thing I didn't want to show you guys is coding best practices. So there's this part where PEP 8. So this is something I think I will talk about maybe before. I realize I have a bunch of drawings on my screen. Okay. We'll talk about this actually maybe tomorrow at 1 p.m. Eastern time for our next study group. And we'll go over those parts as well as like new imports and everything like that. But I want to share this with you guys. You can find this. So, and I will share this out in, sorry, I'm thinking real quick. I will share this link out. Basically, the stuff from the study groups are specifically, I keep them all on this GitHub repo for you guys to reference. So for example, the stuff we talked about was like Git. So if I go to Python basics, and I'll show you guys exactly where to go. Version control, you can see, for example, Git. You can see those up the Jupyter notebook of what we talked about today. So this way you guys can reference it too. One thing you can do, for example, you can clone this or fork this. That way you have it for yourself. Just know if I make updates and stuff like that, you'll still have to do basically sync it up by the git pull. But I'll talk about that next time too, about how you would even deal with this. But I'll send out this link so that way you guys are at least familiar where you can find this information. Okay, cool. All right, everyone. Well, I do have to head out. I do see most people have 1-on-1 set up. If you haven't yet, make sure you do that. If you're not sure what I'm talking about or how to do it 1-on-1, just send me a message. I'm pretty booked, I think, for this week, but we can maybe at least do it for next week or at least talk a little bit on Slack on how things are going. All right, cool. Well, take care, everyone, and I will see you all around.